So this is 3-3 Part B because my equipment failed on me and I couldn't see any more of what you could see, which is kind of hard to do when you're rewriting like this. So we are still on section 3-3 and it is page 33. And we've actually covered the concept of a truth value and the pattern. Hopefully you were able to see it. I'm not really sure when the video kind of stopped working on my computer. The pattern is that the original statement and the contrapositive will have the same true or false value. And we can see that here as well. And then the converse and the inverse will have the same true or false value. So the last thing, we were really close to the end, the last thing we need to talk about is something called a biconditional statement. So on a conditional statement, we start with, if you do the dishes, then you can go to the movies. So a biconditional means that it works both ways. So it's an if and only if. And it gets a little bit weird, like you can go to the movies if and only if you do the dishes. Well, that means you can go to the movies if you do the dishes, and if you do the dishes, you can go to the movies, that they work both ways. Well, not everything is a biconditional statement. Like this guy right here, if a figure is a triangle, then it's a polygon. Okay, that's true. But a figure is a triangle if and only if it's a polygon? That feels a little weird. So a biconditional statement, like the example they've given us, write the definition of perpendicular lines in a biconditional form. No, our book never defined perpendicular lines, so how would you be able to do that? We're going to do it this way instead. Let's see. I can go to the movies if and only if I wash the dishes. So, I can go to the movies if I wash the dishes. If I wash the dishes, I can go to the movies. An if and only if statement means that you can read it either direction and it works. Now you might be wondering, like, what do you mean either direction? If both the conditional and the converse are true, then you have a biconditional statement, meaning both directions work. Here's an example. So, let's see, I'm trying to think of a good one, and of course at this point I'm so frustrated with my equipment, not zooming in and out, and it stopping right in the middle of my video. My mind has gone completely blank. So let's turn the page and steal one. Here we go. Number 10. Consider this statement, all birds have wings. I kind of feel like that is a pretty darn true statement. Can we write that as a conditional? Yes. If an animal is a bird, then it has wings. Can we write it as a biconditional statement? If and only if an animal is a bird, then it has wings? Or an animal is a bird if and only if it has wings. Well, okay. Let's say that again. A biconditional statement. Could we turn that into something that's always true both ways? If I have a bird, then it has wings. Unless the bird has some deformities, then that would be true. If an animal has wings, then it's a bird. Do both statements work? No. Can you guys think of some creatures that have wings that aren't birds? Butterflies, flies, bumblebees. Yeah, and I know you might be like, but that's not an animal, that's an insect. Well, the use of the word animal is going to be a little bit generous there. So we cannot turn that into a biconditional statement. So I'm sorry that I had to do another 5-minute video. I'm hopeful that this is making some sense. This is always a tough one because it just feels like you're talking and writing things in circles, and I get that. So let me know how I can help.